Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's webinar, Fundamentals of Cisco Networking Technologies. Presenting today's topic is Robert Piper. Robert is a well-versed Cisco Certified subject matter expert. Having spent over 34 years in the information technology industry, he has provided corporate training, including hands-on and virtual practice labs that feature the latest Cisco equipment. The time spent in the IT industry speaks volumes of his knowledge and expertise. His training programs use real-world, relevant scenarios to help professionals prepare for on-the-job networking environments and Cisco certification exams. Now, please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Networking Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. Today's session will provide an overview of fundamentals of Cisco networking. This webinar is perfect for those interested in pursuing a career in network engineering or those looking to enhance their networking skills. And now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the Handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hi, Robert. Thank you so much for joining us today.
Good afternoon. Thank you for the introduction. My name is Robert Piper, and before we start, I'll just go over the agenda for today's content. We're going to introduce you to Cisco Networking, provide an overview of some of the fundamental network management tools that we use on a day-to-day basis. We're also going to introduce you to some of the devices and topologies that make up our network in today's enterprises. We'll give you an overview of the Internetwork operating system. We'll also talk about the approach that Cisco recommends when troubleshooting network issues, and then we'll open it up for a few questions and answers at the end. So without further ado, we'll go ahead and get started. The first thing we'll show you, this slide actually identifies the Cisco enterprise architectural model. And Cisco has developed this model that separates the network into functional areas called modules. The reason for this is that it allows for flexibility when designing your network, as well as facilitates the implementation of the network when building it. And also what's important is being able to troubleshoot the network. So let's investigate this model in a little bit more detail. If you look closely, the enterprise campus could be a large site that may be the corporate headquarters, for example, of a Fortune 1000 company. And then within the enterprise campus, you'll see a data center, which is located within the campus, and it's responsible for managing and maintaining all of the systems that are vital to most modern business operations. So employees, their partners, customers, all rely on resources within the data center in order to create, collaborate, and interact with each other. A high-speed, high-capacity, centralized data center module gives users and provides access to internal server resources, including application, file, print, and email services, while at the same time supporting network management services for the entire enterprise, things that include monitoring, logging, and troubleshooting. The next module that we'll find in the enterprise campus is what we refer to as the LAN core. This is where high performance switched backbone is located that connects the buildings to various parts of the campus, as well as providing access to the corporate network across the wide area or the web for remote sites, including branch offices and small office, home office, as well as our mobile workers. And the LAN core connects to the LAN access module, which grants end users access to the terrestrial network, including routing and switching traffic as quickly as possible from one module to another using multi-layer switches and high performance throughput, while adding things like routing, quality of service, and security controls. So how do we manage all of this? Well, the ISO, or International Organization for Standardization, that's the organization that gave us the well-known 7-layer ISO reference model. They've defined 5 key areas of network management, including configuration management, which allows a network manager to track which devices are on the managed network and the hardware and software configurations of those devices. They also or I should say, the goal of performance management is to quantify, measure, report, analyze, and control the performance of different network components. Third, the goal of fault management is to log, detect, and respond to fault conditions on the network. So the line between fault management and performance management might appear a little blurred. Think of fault management as the immediate handling of a network failure. Let's say a link goes down or a router has a hardware problem, we have a software outage, while performance management takes a longer term view of providing acceptable levels of performance in the face of different traffic demands. 4, the goal of security management is to control access to network resources according to a well-defined policy that you've created for your organization. It would include the use of firewalls to monitor and control external access points to one's network is another crucial component. And 5, accounting management allows the network manager to specify, to log, and control user and device access to network resources. So things like usage quotas, usage-based charging, the allocation of resources, access privileges, all fall under what we call account management. So what exactly is this thing that we call network management? Well, in a phrase, network management is the process of administering, managing, and operating a data network using a network management system. And modern network management systems use both hardware and software to continually collect and analyze data, and also to push configuration changes in an effort to improve performance, reliability, and security. Now, as technologies modernize their infrastructure, they face a host of obstacles, including how to support legacy infrastructure, poor systems integration, and perhaps teams whose programming skills may not be up to snuff. So whether an IT professional team needs to deliver new apps, or whether they need to deliver new apps or deliver new applications to create a more efficient environment, it seems that legacy IT gets in the way. By contrast, as our modern infrastructure adapts, it helps IT professionals keep pace with the business requirements. So to create a modern and more responsive infrastructure, companies have virtualized the data center infrastructure from servers to storage to networking. And then combined with analytics, things that you're going to hear going into the future, like virtualization, helps the network stand up to these demands. And as hardware becomes virtualized and programmable through software, teams need the skills. You as individuals require the skills to enable this integration. And the hardware needs to be able to integrate. So how you as an IT professional choose your tools and design your IT environments to be automated, virtualized, programmable, secure, and scalable is going to be the difference between success and failure for a lot of companies. And for all of us, security has been a main concern, right? So as new devices are introduced into the network and as companies connect to branch offices through the internet, you and I need to continually secure the entire continuum, from the edge of the network to the data that travels on the network to mobile devices to sensors connected to the Internet of Things. And as these devices continue to proliferate, the attack surface just widens, right? And companies need to develop a security process that protects their content that carries sensitive data, as well as the data in motion and at rest. So one of the defining characteristics of a modern network management system is what we refer to as network automation, which is the process of automating both the configuring, the managing, the testing, the deploying, and the operating of both physical and virtual devices within a network. And as your network service availability improves and you take the tasks that we perform every day and automate those instead of continuing a repetitive process, those things will add to the flexibility and the ability for us to support a network that's performing properly. And network assurance features are often included in a modern network management system. And these features will protect as well as enhance network performance. They'll improve the user experience and security. So assurance systems also often use network analytics, application analytics, artificial intelligence, and machine learning to achieve this full network assurance. We'll talk about that in a little bit. So we'll introduce you to something called intent-based networking, which is an emerging technology concept that aims to apply a deeper level of intelligence and intended state insights of networking. And these insights are designed to replace the manual process of configuring networks and reacting to network issues. Simply put, an administrator can send a request to tell the network what outcome they want, i.e. the intent, instead of needing to code and execute individual tasks manually. So what is the purpose, the primary intent of intent-based networking? Well, the primary purpose is to use machine learning and cognitive computing to enable more automation and less time spent on manual configuration and management. So again, the network administrator can define the outcome or business objective, the intent, and the network software figures out how to achieve that goal thanks to artificial intelligence and machine learning. So there are some clear advantages over regular networking and even over things like software-defined networking. One is the reduction in manual tasks, faster troubleshooting and resolution, reduced risk of being out of compliance on your software applications, improved security, optimized analytics, and also rapid implementation of business goals and objectives into your network configurations. Cisco has a product called the DNA, or Digital Network Architecture, and that's the central platform of Cisco as a bridge to intent-based networking. So Cisco DNA is generally used by both medium and large companies to manage their operations in a single dashboard. There's a single appliance that sits on the network, and it allows you to view all of the networks in one platform, and they become less faulty, they perform better and more secure. And if you look at this slide, the interconnection of both the automation and assurance performs what we call a continuous validation and verification loop, checking the alignment of the way that your network is operating with the business intent. So it's going to be a bridge for your team and your organization to intent-based networking. Again, with Cisco DNA, network operations costs will continue to improve. Your network jobs are going to be simpler, and you'll have an opportunity to minimize your risks. So people often draw diagrams or pictures to help describe complicated things, yes? So maps, for example, are pictures of routes to get from point A to point B. Instruction manuals use diagrams to help us figure out how we put things together. When we use the word topology, we're referring to how things in our network is connected, as in a configuration. So we've got an example of two types of topologies here, both the physical and logical topology. A physical topology describes how network devices are physically connected. In other words, how devices are actually plugged into each other. So we're talking about things like cables, wireless connectivity, etc. A logical topology, on the other hand, describes how network devices appear to be connected to each other. So for example, in a logical diagram, perhaps of your office network, you might show a connection between Atlanta and Boston. But in the actual physical network, your data may, in fact, go through switching points in several other cities as well. The logical path, therefore, is a high-level representation where the physical path is the actual route that your data is going to take. So we've got an example of a couple of different types of topologies here. A bus topology consists of a main run of cable with a terminator at each end, and all devices like workstations, printers, laptops, servers, they're all connected to a linear cable. And then the terminator is used to absorb the signal so that when the signal reaches the end, it prevents what we call signal bounce. In a ring topology, the next one, all of the devices are connected via cable that loops in a ring or a circle. And since there's no beginning and no end, there's no need for terminators in a ring topology. So signals travel in one direction while they pass from one device to another, with each device regenerating the signal so it can travel the distance that's required. The main advantage of a ring topology is that there's no signal degeneration, or very little, I should say, since each workstation participating in the network is responsible for then regenerating a weak signal. The disadvantage of a ring topology is like a Christmas light, for example. If one workstation fails, the entire network will fail. The star topology is the most popular topology in networking today. It's designed with each device connected directly to a central device, typically referred to as a switch, where each workstation has a cable that goes from its network interface card to a switch port. And one of the reasons why it's one of the most popular is that it's easy to install and cable up. There's no disruptions to the network when connecting or removing devices, so it's plug and play. You can easily detect faults to remove parts. It requires a little more cable length than a linear bus topology. And if one of the devices in your network switch fails, everybody else is still connected. And then the last one, the mesh topology, that's a topology where every device is connected to every other device in the network. And this is a costly, or can be a costly topology because of all the extra cables that are required. It's also complex and difficult to manage. The main advantage of a mesh topology is that you have multiple paths to a destination device. So if you lose one of those links, you've got another path to reach the destination. So both the logical and physical topologies, as it refers to our network diagrams, are effective, are key to effective network and in infrastructure management. So when you maintain up-to-date diagrams, admins, network engineers can troubleshoot and therefore minimize downtime. You can plan for capacity, you can avoid clutter, maintain your software, and keep the network secure and compliant. So we said that the physical network depicts the physical topology and how the devices are actually connected. And while that physical network diagram is important, typically we're going to use a logical diagram to make network management easier in a number of ways. Number one, if a service is out somewhere between two IP addresses, as an example, you can use a logical diagram to rule out any issue caused, for example, by a firewall. You can also ensure that your firewall rules stay accurate. A logical diagram will also help you determine what is and what is not redundant. You can also do capacity planning because you can map out your expanding or changing network requirements and see what impact it's going to have. And also, if you need to share information about your network, but you want to conceal some of the physical information about your devices, you can use a logical network diagram instead. So basically, a network diagram like this is showing the connection between host A and the server without necessarily talking about the two switches and the default gateway that the data has to go through. Here we'll talk about some of the components that make up our network. We've got switches, routers, wireless access points or APs. They are the basic networking devices that allow endpoints connected to your network to communicate with one another and other networks, like the internet. So a switch is at the foundation of most business networks, acting as a controller. It connects your PCs, your printers, and servers to a local area network in a building or a campus environment that allows devices on your network to communicate with each other as well as other networks, thereby creating a larger network of shared resources. Routers facilitate the forwarding of packets from one local area network to another, or service providers' wide area network for access to the internet or the World Wide Web. So routers allow all of your network endpoints to share, for example, a single internet connection. A layer 3 switch combines the functionality of both a switch as well as a router. It acts as a switch to connect devices that are on the same subnet or VLAN, and it also includes some routing intelligence built in, so it doubles as a router. So it can support multiple routing protocols, it can inspect incoming packets, it can make routing decisions based on the destination IP address. And we often refer to a layer 3 router as a multi-layer switch, and it can add a ton of flexibility to your network. So how does a network management system do its job? We'll talk about that a little bit further. But when we talk about how we manage the network devices like these switches, routers, access points, wireless controllers, again, we can typically use a centralized server to collect data from all of these network elements. And then that server can be located on premise, it could be in a private data center, or in the cloud. So both devices, clients, applications that are on our network can send data to the server with updates about their status. And then network administrators that have responsibility for managing the network can monitor operations of all of these devices by logging into the server, using usually through a web browser or something as simple as a smartphone app. Now, we'll talk a little bit more about our iOS. We're going to show you through the Cisco Enterprise Architectural Model that the iOS resides on our switches and our routers. And just like your personal computer or your smartphone improves individual productivity, an efficient network improves the productivity of a large group of people, especially in the enterprise environment. So the intelligence lies in the operating system of the network. So the network hardware inevitably changes every few years with the introduction of new generations of processors, switching, and memory components. But the software is the unifying thread that connects these disparate networks and provides a scalable migration path as a company's needs evolve. So as a networking engineer, you'll be able to operate the Cisco iOS software and perform various tasks, including entering commands through the CLI, using the help functionality in the CLI, and you also need to be able to navigate various modes of the CLI in order to support your infrastructure devices. So the iOS, or Inter-Network Operating System, is a proprietary operating system that provides routing, switching, and internetworking features. It controls and manages the hardware that it runs on, and it provides an interface between the user and the hardware that allows the user to execute commands to configure and manage the Cisco device. So as user, we're talking about the administrator. Now, originally, the iOS was developed for Cisco routers, but a few years later, Cisco decided to use the iOS on its other platforms, including the entire line of Catalyst switches. And currently, the iOS runs on all of the Cisco routers, as well as a growing number of Catalyst switches like the 2960 and the 3560 series switches. Now, the iOS does a lot. It's responsible for carrying the network protocols. It's configured to connect between different data link layer technologies, to connect high-speed traffic between devices, to secure the network, to control unauthorized access, to provide scalability, to keep the network stable and reliable. So let's talk about it in a little bit more detail. The iOS, we said, was a proprietary operating system that runs on our Cisco devices. And Cisco releases are organized into what we call families or trains, where each family shares the same code base, and trains are how new iOS releases are delivered. And the first iOS was written in 1986 by a guy named Bill Yeager. Since then, to keep the iOS up to date and to ensure that resources always remain accessible, there are new technologies that are introduced, and they're added, those updates are added in every feature. And there's two types of iOS operating systems. There's iOS XE that runs on top of a Linux kernel, and then there's iOS XR that's based on QNX, which is a commercial Unix-like real-time operating system. Let's take a look at the iOS command line interface, or CLI. It provides a fixed set of multiple word commands, and what's available is determined by the mode and the privilege level of the user. So global configuration mode allows you to commands to change the system's configuration, and interface configuration mode provides the commands that allow you to change the configuration, for example, of a specific interface. All of the commands are assigned to a privilege level from 0 to 15 and can only be accessed by users with the appropriate privs. And it's through the CLI that commands are available to each privilege level where you can define those. Now, routers and switches are manufactured in two types of hardware platforms: fixed chassis and modular chassis. And if a router or a switch is built on a fixed chassis platform, then we've got to use it like it is. We can't, for example, add additional ports or interfaces to it. And at the same time, we can't remove any interfaces or ports. But if a router or a switch is built on a modular chassis platform, then we can install the interfaces or ports of our choice. So this modular router or switch has a few empty slots along with the fixed ports that allows us to install interfaces or ports of our choice. And you can use the iOS running on a device to connect two different networks that use two different media types, like to connect a LAN network to a WAN or to connect a wireless network to a wired network. And then after you establish an exec session, then the commands within the iOS are actually structured in a hierarchy. And when you come to class, you'll understand how important that hierarchy is to successfully configure a Cisco device. Commands, options, applications all vary depending on your position within that hierarchy. So configuration command options are not available until you've navigated to the appropriate configuration branch of the iOS. And when you're in the configuration branch, you can, in fact, enter system level configuration commands that apply to the entire device at the global config level. Interface specific config commands, they're available when you switch to the interface configuration level. And you'll also notice that your prompt will change as well, depending on where you're actually located. And there's actually over 100 modes, but typically the more popular modes are user exec mode, privileged mode, global config mode, ROM monitor mode, setup mode. And the iOS includes a wide range of security features that allow you to strictly control your network resources and your devices according to your security policies. So you can configure the iOS to allow or deny a specific host or a range of hosts. You can also configure the iOS to allow or deny access to a particular application. So we've got an example on the slide here of one of our security policies known as an access control list, or ACL. And it's configured through the iOS that actively monitors all of the traffic that passes through it and allows or denies that traffic based on the configuration rules. For example, if the iOS receives traffic from a host that is blocked in the ACL, the iOS discards that traffic immediately. Or if the iOS receives traffic from a host that is allowed through the access list, then the iOS processes that traffic and then forwards it to the destination. And as a security feature, we mentioned that the iOS separates exec sessions into two separate access levels: user exec and privileged exec. User exec allows you access to basic monitoring commands, where privileged exec allows you access to all of the router commands on that device. And privileged exec can be password protected to allow only authorized users the ability to configure or manage the router. So from privileged exec level, you can access all of the command modes. And we mentioned those 5 that include global config, interface config, sub interface config, router configuration, and line configuration mode. And as I referenced here a minute ago, to assist you in navigation through the iOS CLI, the command prompt changes to reflect your position within the hierarchy, which allows you to identify where you are at any given moment. Now we'll talk about troubleshooting methodology. How do we troubleshoot when things go wrong? So most modern enterprises depend heavily on the smooth operation of their infrastructure. So any type of downtime usually translates into a loss of productivity, a loss of revenue, and perhaps a loss of reputation. So network troubleshooting is one of the essential responsibilities of the network support group and you and I as individual contributors. So the more efficiently and effectively the network support personnel can diagnose and resolve problems, the lower the impact and the damages will be to the business. So in a complex network environment, troubleshooting can be a daunting task, and the recommended way to diagnose and resolve problems quickly and effectively is by following a structured approach. So structured network troubleshooting requires a well-defined and documented troubleshooting procedure. Troubleshooting is not an exact science. So a problem can be diagnosed and sometimes solved in a number of different ways. However, when you perform using a structured troubleshooting approach or methodology, it allows you to make continuous progress and usually solves a problem faster than it would if you took an ad hoc approach. And there's a number of different troubleshooting approaches. For some problems, one methodology might work better, whereas for others, another method might be more suitable. So it's beneficial for you and I to be familiar with a variety of approaches so we have the ability to select the best method or combination of methods in order to solve a variety of problems. So we're going to go through a few of those in the next couple of slides. So we said that troubleshooting is the process that leads to the diagnosis and, if possible, the resolution of a problem. And it's usually triggered when you pick up the phone, right? So a person reports the problem. And so it's the reporting of this problem that triggers the troubleshooting process, which starts by defining what the problem is. So what you see on this slide illustrates the primary elements of a structured troubleshooting methodology and the transition from one step to the next. So gathering information, that happens after the problem's been reported. And this might include interviewing all of the parties, the users involved, plus any other way of gathering relevant information. And usually the problem report may not contain enough information to formulate a good hypothesis without first gathering more information. So information and symptoms may be gathered directly. They could be gathered by observing processes or indirectly by executing tests. So then after the gathered information has been analyzed, the troubleshooter compares the symptoms against his or her knowledge of the system, processes, and baselines to separate what's normal from what is abnormal behavior. And then by comparing the observed behavior against what's expected, some of the possible problem causes can be eliminated. So after gathering and analyzing information, eliminating the possible causes, one or more problem causes will still remain. The probability of each of these causes will have to be assessed in as the most likely problem that caused this particular issue. And then we're going to test our hypothesis, right? We've got to test it, confirm, or deny that it's the actual cause of the problem. The easiest way to do this is by proposing a solution based on our hypothesis, implement that solution, and then verify whether it solved the problem or not. And if this method is impossible or disruptive to live equipment, we might have to do it after hours, or our hypothesis could be strengthened or invalidated by gathering and analyzing more information. But the key here, the takeaway is that if we do not take a structured approach to troubleshooting and go through the actual steps in an ad hoc fashion, we might eventually find the solution, but the process in general is going to be very inefficient. So we'll talk about a couple of different troubleshooting methodologies called the top-down, the bottom-up, and the divide and conquer method. So as its name implies, when you apply a top-down approach to troubleshooting a network problem, you start with the user application and you work your way down the layers of the OSI model. If a layer is not in good working condition, you inspect the layer below it. When you know that the current layer is not working, and then you discover that a lower layer works, you can in fact conclude that the problem is within the layer above that lower working layer. So after you discovered which layer is the lowest layer with problems, you can begin identifying the cause of the problem within that layer. And you usually choose the top-down approach when you have reason to believe that the problem is most likely at the application or the other OSI layers. The bottom-up approach to troubleshooting a network problem starts with the physical components of the network and works its way up the layers of the OSI model. And this methodology is effective and efficient for situations when the problem is suspected to be physical. And most networking problems reside at the lower levels, so implementing the bottom-up approach often results in both an effective and fast identification and fixing the problem. The divide and conquer approach, unlike its top-down and bottom-up counterparts, doesn't always commence at a particular OSI layer. So you're going to select the layer and test its health, and then based on what you observe, you might go in either direction, either up or down from the starting layer. The layer that you ultimately select is the one that is faulty, and the layer below is in good working condition. And during the course of divide and conquer, if you verify that the layer is functioning well, you can safely assume that the layers below it are functioning as well. Another common troubleshooting approach is called the perform comparison approach, with what I affectionately refer to as the stare and compare. You might also hear it referred to as spotting the differences. So you compare configurations, maybe software versions, hardware, other properties, between a device that's working and a device that's not working to see if you can identify differences between them. The follow the path approach is one of the most basic troubleshooting techniques, and it usually complements one of the other troubleshooting methods like the top down or the bottom up. The follow the path approach discovers the actual traffic path all the way from source to destination. And then the scope of your troubleshooting is reduced to just the links and devices that are actually in the forwarding path. Also called move the problem, the swap components approach is a very elementary troubleshooting technique that allows you to isolate a particular problem, where you physically swap components and observe whether the problem stays in place, whether it moves with the component, or hopefully disappears entirely. And one of the most useful troubleshooting techniques for diagnosing network problems is to review the network operating system's built-in event logs. These logs contain information about interesting and potentially troublesome events that occurred during the daily operation of your network. And ordinarily, these logs run in the background, quietly gathering information about the network events. And when something goes wrong, you have the ability to check those logs to see whether the problem generated a noteworthy event. In a lot of cases, these logs contain an entry that pinpoints the exact cause and the time of the problem and suggests a solution. And by default, wireless devices send the output from these messages to a logging process that controls the distribution of these messages to various destinations like a logging buffer, maybe a terminal line, or a syslog server, depending on your configuration. You can also have those messages sent directly to the console. You also have some tools that are in your virtual tool bag. You have a ping, traceroute, telnet or secure shell. You can issue a show IP ARP or show ARP or show IP interface brief. So for example, a successful ping tests up to and including layer 3 of the OSI model. Layer 1 connectivity can be established by a link light. Layer 2 connectivity is established by checking if a protocol shows up or you have the ability to see the MAC address itself. Here we've got a successful ping from source to destination. And when a normal ping is sent from a router, the source address of the ping is the IP address of the interface that the packet uses to exit the router. If an extended ping is used, the source IP address can be changed to any address on the router. And that's used to perform a more advanced check of host reachability and connectivity. And we do that from the privileged exec command line. The normal ping works in both user as well as privileged exec mode. Here's an example of a traceroute command, which is a command line interface that's used to identify the path that the packets are taking from source to its target destination. This tool uses ICMP messages, but unlike ping, it identifies every router in the path taken by the packets. And it's useful when troubleshooting network problems because it helps us identify perhaps where the problem might reside exactly. So you can figure out which router in the path is unreachable, and you can examine that more closely as the probable cause of the network's failure. And the way that this works is that it sends a series of ICMP echo requests and replies. The first series of messages has a time to live set to 1, meaning that the first router in the path will discard the packet and then send an ICMP time exceeded message. And then that time to live is increased by 1 until the destination host is reached. And then what the utility does is it combines all of those series of ICM echo requests and replies to give you to identify every single router between the source and the destination. So here's an example of an extended trace route that can test connectivity from a specified source, in this case, the loopback 0 interface. Here's an example of telnet. So poor telnet, it used to be the cool kid on the block. It was the program that all system admins turned to when they needed to connect to a remote server. The problem is that telnet just wasn't that good at keeping a secret. Why? All of the communication is sent over plain text. So administrators who are concerned about security, which we all should be, started switching to secure shell for encrypted remote sessions. And of course, along with the switch came a huge stigma against admins who still use telnet. Eventually, telnet became an outcast, the program you used if you were an out-of-touch old-timer who didn't care about much security. But there are a lot of ways to test whether a network port is listening on a system. In this case, if the remote port is unavailable, then I'd fall back to some other form of troubleshooting in order to figure out. And as you can see from this example, the syntax is to type the command telnet, the IP or host name to connect to, and then the remote port. So for example, if I wanted to test a web server, then I would connect to the HTTP port, which in this case would be port 80. So here is the flow or the workflow of troubleshooting. And we're utilizing the output of the show interface command to verify the status of the interface, to check for excessive noise, and to also check for excessive collisions. There are three primary categories of failure in the network. It could be a hardware failure, software failure, or configuration failure. So we can utilize the utilities in our virtual toolbox like ping and traceroute to determine where exactly the problem may exist. And then we want to make sure that we have the correct cable. We can do the swap method to swap a potentially bad cable or suspect cable with a known good cable. And then here's some of the output from the show interface command. And there's several things we can check with the output. Let me describe them. So here we're seeing that gig 01 is up and the line protocol is up. This means that the interface is physically up and the protocol is operational. Then we look at the input queue. That tells us how many packets are in the queue and its maximum size. Drops is the number of packets that have been dropped. We can also identify the queuing strategy, the output queue. That's the size of the queue that shows the current packets, any output errors, any input errors, as well as collisions. So there's a lot of information that we can gather from looking at the output of the show interface command. And that's all of the content that I had for this afternoon, folks. Do we have any questions?
Thank you, Robert. That was most informative. I know everyone is looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And now I'd like to give the presentation rights over to Robin, our vendor manager, to introduce our promotions and webinar-related courses.
Thank you for extending to me this opportunity to speak with our audience today. I would like to thank the audience attending this session and sincerely hope that it added value to your knowledge of fundamentals of Cisco networking technology. And in case you feel like revisiting this session, you can do that by clicking on the access recording button, and we would be happy to make it readily available to you. Next, I would like to offer you a glimpse of Netcom Learning's capabilities and why we are the best that there is when it comes to learning services, training, talent development, and beyond. I take pride to announce that Netcom Learning is the winner of 2022 Microsoft Learning Partner of the Year Award, which was recognized by Microsoft, and Netcom Learning earned this top spot out of 3,900 submitted nominations from more than 100 nations across the globe. Netcom Learning has been into managed learning space for 2.5 decades now and have provided its services to 80% of the Fortune 1000 companies. Having a strong reputation in B2G sector, Netcom has served over 100 US military bases. We have trained over 175,000 professionals to learn and grow in their respective fields across 16,000 enterprise clients. And we cherish a recommendation rate of 96% from our customers. All the numbers I just mentioned have been a result of our specially curated trainings delivered by a portfolio of 3,000 plus certified trainers. Moving ahead, being an authorized Cisco Learning Partner, I would like to announce Netcom Learning's upcoming schedule of classes on Cisco trainings that you can explore through this handout. To add value to your learning curve, we encourage you go through our free on-demand webinars and blogs on Cisco networking through this handout and also through our website under the resource section. You can also take advantage from Learning Passport, which is Netcom Learning's solution to a flexible team training. It is designed to be customized in line with the number of learners that you plan to train from top technology vendors like Microsoft, Cisco, Adobe, and more. The single package can be redeemed over 4,000 plus official courses with a validity of 12 months. Keeping in mind the requirement of our customers, you can further choose from Learning Savings Passport or Learning Voucher Passport. as per your need and requirement. Next, I would like to introduce you to Netcom Plus, a learner subscription, a learning solution that we have developed for our enterprise customers. All you are required to do is invest one time and reap the benefits of the unlimited access to authorized trainings from top technology vendors like Microsoft, AWS, Cisco, and more through a span of 12 months. As displayed on your screen, we deliver the subscription in three types of packages. The free or the silver package allows you to access 300 plus e-learning modules, or you can go for gold at $199. That gives you an access to 400 plus e-learning modules along with silver package benefits. Third, we have for you our best-selling and most popular platinum package at $2,999. That gives you an access to 400 plus e-learning modules along with 120 plus virtual instructor-led trainings in addition to the gold package. I would also recommend you go through Netcom Learning's website for more information such as courses and certifications, our free virtual events, blogs, and promotional offers. If you're looking for a leadership point of view on the importance of lifelong learning and building a smarter workforce, I highly recommend you go through the book Building an Innovative Learning Organization by Russell Sarder, CEO, Netcom Learning. You can easily find it on Amazon. I sincerely hope we could add value to your knowledge base in the time you choose to spend with us during this webinar. For more information on such sessions and latest updates on IT and business training, please follow us and give us a shout out on LinkedIn, Instagram, YouTube, and Twitter channels. Thank you once again for joining us.
Thanks so much for guiding us through all that information, Robin. And now we're going to go ahead and jump right into our question and answer session. If you haven't yet, it's not too late to pop your questions into the question panel. And as we start our Q&A sessions, we're also going to launch a quick poll that we want to invite you to participate in. Doing so helps us to know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register. The first question we have today is, what similarities or differences do you see between network monitoring and network management?
Well, in my opinion, network monitoring is part of network management, where network monitoring is the use of a system or appliance that monitors the entire network, and you're looking for slow or failing components that notifies the network administrator either via mail or text or other alarms in case of outages or other trouble. Network monitoring is part of a network management system.
Next question is, what is network automation?
Network automation is the process of automating the configuring, the managing, the testing, and the operation of your physical and virtual devices within a network. And when you take those everyday tasks and functions and you automate those, your service availability improves. And any type of network can utilize automation. So hardware, software-based solutions allow the data center, various service providers, and enterprises to implement automation to improve efficiency, reduce human error, because we fat finger things occasionally, and also to lower the operating expenses.
And finally, what is the need to automate the network?
Well, one of the biggest issues for IT managers today is the growth of costs, specifically for supporting the network. So the growth of data and devices is starting to outpace the capabilities of IT, which makes manual approaches nearly impossible. Yet up to 95% of network changes are still performed manually, which result in an operational cost that's 2 to 3 times higher than the cost of the network itself. So as we increase the way that we automate, manage our network, it's really essential in order for businesses to keep pace with the digital world. And that's why it's so important for you and I to keep our skills up and engage in companies like Netcom Learning in order to upscale your skills, learn about network automation, identify the things that are going to be important going into the future so that you can continue to be marketable here in this ever-changing network community.
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.